Okay, let's do a video on 11.7. Okay, so 11.7 just basically sums everything up. So, what do you do when you have a series? You guys, the series of things you run to look at the series. The first thing I will do, I look at the series, I pull out the ANs, I check AN. So the first thing I'm going to do, check AN. And if AN does not go to zero, if the sequence part of the series doesn't go to zero, it diverges and you stop. Um, if it ANs go to zero, you continue. Keep working. Okay, so the second thing I'm going to look at, I'm going to see if the ANs look something like a number times R to the n. If they do, this is going to converge to first over 1 minus r. Why am I saying that? Because I already said that they got to go to 0. If they got to go to 0, then this guy's going to be less than 1. Okay? So that's the geometric series, and we know exactly what the geometric series go to. And if this guy's bigger than 1, they diverge, but we already said that the ANs went to 0, so this guy's got to be less than 1. Okay, and if that's not true, if that's yes, do that. If not, then you continue. What's the next thing I might look at? So 3, do the ANs, do they kind of look like a 1 over n to the p? If so, then if p is less than 1, it converges. If p is greater than or equal to 1, it diverges. If that's not true, then you continue. What's the next thing you're going to look at? Okay, so that'd be the fourth thing you look at. Then I'd ask myself, does the or do the ANs look like something I could integrate? If yes, then you got to go find F such that it's decreasing, positive, and continuous. And the last thing is that F of n's equal AN. So do the ANs, these look like something like you integrate, turn them into X's, and see if you can find a function that's decreasing, positive, continuous, and at the integers they match the sequence part. Then what are you going to do? You're going to do the integral test for convergence. Okay, if that's true, do this. If not, you're going to continue. What's the next thing you're going to look at? Make sure I haven't skipped anything yet. Okay, so fifth thing you look at, does AN look like something you know? Like, do the ANs look like kind of look like a P series, or do they kind of look like a geometric series, or do they kind of look like something you've already worked with dealing with when you did it with the integral test? If they do, you're going to use the comparison test or the limit comparison test. If you got to know if it doesn't look like something you know anything about, then you continue. Okay, run out of board space, so let's erase all of this. I'm going to come back, start up. Number 1, I'm going to make that number 6, or it's number 2, 2. Okay, so if that doesn't work, what's the sixth thing you're going to check? Is it alternating? You know, does it have a -1 to the n or n plus 1? If it's alternating, if it is alternating, then what are you going to do? You're going to see if these guys are decreasing. If those are decreasing, you've already showed that these guys are going to 0. If these are decreasing, it's alternating, it converges. Okay? If it's not alternating, so you've looked at it, doesn't pass anything you've done so far, came back, it's not meeting the alternating series test, what's the seventh thing you're going to look at? At that point, if it's not alternating, kind of run out of things to look at, you're going to use the ratio test or the root test. Okay, so let's go back through it. First thing you're going to do, you grab this guy. If the insides don't go to 0, you can quit. You're done. If they do go to 0, then I'm going to check and see, is it a geometric series? Look like geometric. If it's geometric, I'm happy because I'll know the exact answer. Or does it look like a p-series? Looks like a p-series, I won't know the exact answer. We'll at least be able to tell if it converges or doesn't converge. If it's neither one of those, then I'm going to check and see if it looks like a p-series. Nope. I probably would look and see if it's something I can integrate, or I wanted to integrate. Okay, if I could integrate it, then I'm going to look for the proper f and then use the integral test on it. If that doesn't work, then I'm going to see if it compares to something. Does it look like a p-series that I know something about? Does it look like a geometric series? If it does, I'm going to use a comparison test or limit comparison test. And I might skip over the integral test and go straight to comparison test if I automatically knew, yeah, it looks just like this. If it doesn't pass any of those, then I'm going to see if it's alternating. If it's alternating, I'm happy because alternating test is really easy. All you got to do is show it's decreasing and going plus, minus, and I know it converges, and I also know a bound for that stuff. If it's none of those, then I'm going to go to the ratio test or the root test. And the ratio test, like I said, this is the biggest guy. Sometimes I just skip everything and just go straight to the ratio test because I don't want to waste time looking at all the other stuff. And the big thing on ratio test, if I see it's got a factorial in it, I'm going to use the ratio test. Doesn't happen very much, but if I see the whole thing's raised to the nth power or something with the nth power, I'm going to go straight to the root test. Now, so those are the kind of how I would go through to see if a series are converged. I would look at the sequence part and compare it to all these different things and see what I could do. Now, so that's the test. Read through your book. They do a pretty good job of listing out a kind of an algorithm on what kind of steps you go through to test to see if a series converges. Now, if they do converge, you'd like to know what an error bound is. Okay? And we only have a few to deal with. That we can work with. Okay, first thing, if it's geometric, if it looks like the summation of some number times an r to the n, we can take that guy, and it's the first over 1 minus r. I know the exact answer for that guy. That's really rare. Usually you don't get the exact answer. You just sometimes you just tell it converges, doesn't converge. If you're lucky, you can tell if it converges and get an error bound. If I showed that it converges using an integral test, I know that the remainder is less than the integral from n to infinity of f of x dx, where f of x was the function that you used in the integral test. If I use the alternating series test, then you know that Rn is less than a n plus 1 in absolute value. Okay, so there's a list of things that I would do to see if the series converges. And next thing I want to see if I can get either the exact answer or a bound on the error, that guy. Okay, I'm gonna quit here and I'll come back and do some examples in the next video.